the vectors for angular radius and angular tangential.
Oh, so that's the radial acceleration and tangential acceleration. Okay.
Make sure the length indicates the relative size of the vector. And then with a red pen or pencil, draw and label the total acceleration of vector. Oh. Okay, so we need to do the angular,
So the radial acceleration and tangential acceleration. We're not talking about angular acceleration this time.
okay.
So angular acceleration only comes up when you see alpha.
Okay, good to know. So, I don't even know. Tangential acceleration, I would think, would simply be this way.
So what would happen if you take this ball, it's kind of on a string, and you swung it all the way around, all the way like up around the top?
We would have a circle.
Right, you draw a circle. So this is following a path. If I can get this marker to work. So it's following a path that looks like this. And tangential acceleration is always tangent to the path. Oops.
Okay.
So it says black for tangential and radial.
And then radial has to deal with the radius. So is that the acceleration that goes on the inside?
Yeah, so that's the one that points straight to the center, which in this case would point straight up the string, right?
Oh no, why would it?
Because this is always your radius right here. If you have a ball on a string, the string is always your radius, and the point that you're holding it at, right here, that's the center of our circle, right? So this is our radius, this is our radius, this is our radius.
How would you know what length to draw it at?
You kind of have to think about what happens. So right here, it's dropped, right? So what would our tangential acceleration look like?
Where?
Right here at this point, right when it starts.
It'd be a diagonal.
So it'd be diagonal, and it'd be pretty big, right? Because gravity is acting pretty strongly at that point, since it's almost falling straight down. So this is a T. But at point 1, how fast is our... So if we want to think about radial acceleration, we have to think about velocity, right? So the higher our velocity, the higher our tangential or our radial acceleration. So we know what it'll accelerate tangentially here, but what's its velocity at that point 1? Right when you let it go.
It's pretty high. Or it might just be 0.
So you've let it go, but it takes some time to speed up, right? So right at this point, this is actually probably 0. So you could even write that in and you say a sub r equals 0. 0 vector.
A sub r is equal to 0. Okay.
So what about number 2?
Number 2 would have a smaller tangential velocity.
Smaller tangential acceleration.
Oh, acceleration, yeah.
So you draw something like that.
So why does this tangential acceleration change and these didn't?
Because those were like just kind of an arbitrary motion around a circle. They weren't controlled by anything exterior. But with a ball on a string, the actual acceleration that's acting is gravity, right?
Mm-hmm.
Acceleration due to gravity. So what we're actually doing is kind of decomposing it
Okay.
into vector parts.
Okay.
So since gravity is always acting straight down, we kind of, if we took it and thought about it right there, this would be the component that would be pushing it out. And then you have a component that pushes it straight down, like tangential.
Mm-hmm.
So you know that this is greater. If you took gravity and drew it right here, this time the acceleration pushing it out towards the end of the string is higher and this one's smaller, right? Now what if you drew your gravity acceleration right here? What does your tangential component look like? So it's 0, right? So it's 0. Then you come over here and you draw it like this. Now what does your tangential acceleration do?
It's increasing.
Well, you want to draw it, so this component would be your radial component of acceleration. Well, ignore that. That's not the actual radial acceleration, that's just
Okay.
the piece of the acceleration due to gravity that acts along this string. But what about this? Which way does the tangential one go? So you need to draw it so it goes to the point. So A sub t goes that way.
Hmm.
Same thing here, you draw your gravity, and you bring it out here, A sub t.